Good day. Welcome to Zuikerbosch water treatment plant, the biggest of two water treatment plants within Rand Water, responsible for 70% of the total production capacity of Rand Water. Zuikerbosch water treatment plant has been expanding to respond to the ever-growing demand in water. The site responsibility is really to support the 12 million customers that Rand Water has. And of course, with the number of years, the number has been increasing to just over 13 million people. The site on its own is divided into 4 water treatment plants. That is System 1 and 2, situated in Works Area 1. And followed by System 3 and 4, situated in Works Area 2, all of which are currently producing a maximum of 3,600 megaliters safely. There are a number of augmentation projects that have been initiated to respond to the ever-growing demand of water. And for that reason, System 5 has been initiated with a capacity of 600 megaliters. We are proudly a blue drop compliant site. The success of this site is really centered around our highly skilled, highly committed individuals, ordinary people whose passion is really to ensure that the 12 million customers receive water. Our daily operations is really guided by the 5 corporate values that are equity, integrity, excellence, caring, and spirit of partnership. And all of those are really meant to ensure that we support Rand Water's vision, which is to be a provider of sustainable, universally competitive water and sanitation solutions for Africa. A life-giving process, a process that shows you the purification of water.
In its quest to meet the ever-increasing water demand and making its services known, Zuikerbosch Water Treatment Plant is embarking on various communication activities to ensure information dissemination of its service offerings. Zuikerbosch Water Treatment Plant is a registered national key point in terms of the National Key Point Act. With the ever-increasing demand for water in the Witwatersrand, the capacity of Rand Water's Vereeniging station was reaching its maximum, and it was decided to build a second water purification plant closer to the Vaal Dam that can augment the supply of water to the gold mining industry. Zuikerbosch Station 1 was then built and commissioned in 1954 and had a nominal capacity of 560 million litres per day. The demand grew so fast that Zuikerbosch water treatment plant had to expand to currently 4 existing stations to execute the water treatment processes. Abstraction. Abstraction of raw water can be done from 2 possible sources. Val Dam Intake Tower feeding the gravity pipeline BG1 as well as the raw water canal. The raw water canal is fed with 2 8.2 km long pipelines and the flow rate is controlled with 4 radial gates situated at control works. At control works, the water is diverted from the pipelines into the canal in such a way that there is no wave action as well as no surges, which ensure that flow in the canal is smooth and steady. The canal is 20 kilometers long, 13 meters wide and 4 meters deep and is the main source of raw water to the site. At the end of the canal, it is fitted with mechanical screens that remove solid waste like debris, grass, algae, fish, etc. from the water. Raw water is then collected in a buffer dam called the forebay in order to accommodate load changes like pump trips, etc. The capacity of the forebay is 500 million litres and raw water is gravitated to the different purification plants from here. Alternatively, water can be abstracted directly from the Vaal River via river intake pumps. Purification and treatment processes. Zuikerbosch applies conventional treatment processes to purify water to the highest quality standards. Coagulation. This is the first step in the water purification process, and it is where the treatment chemicals called coagulants are added to the water. This is normally done under high energy conditions to ensure good mixing with water. In the spiral flocculator, this happens in the center mixing chamber. Typical chemicals that are used to treat the water are hydrated lime, sodium silicate, and polyelectrolyte. The hydrated lime used is prepared on site in slaking plants where lime is added to water during the process. Due to the strategic nature of water, we ensure that we keep approximately 10 days supply of treatment chemicals on site. Flocculation. Flocculation is the pumping together of the suspended matter that has been destabilized by coagulation to form heavier visible particles called floc. The floc remains in suspension as the water flows at high velocity through either spiral flocculates or baffled channel conditioning bays. Sedimentation. During sedimentation, the flow velocity of the water is reduced drastically, with the result that the heavy floc that has formed will now settle under gravity to the floor. Rand Water uses horizontal flow tanks with retention times of ±4 hours and produces water with a turbidity of 5 NTU at the outlet wares, which is considered acceptable for filtration. The clean top layer of water is taken out through launders at the end of the sedimentation tanks. Depending on the turbidity of the incoming raw water, between 95% and 97% of the suspended particles are removed during sedimentation. The floc that settled at the bottom now forms sludge, which must be removed from the sedimentation tank to ensure that the flow of water is sufficiently low to ensure settling of floc. This is achieved through the use of desludging bridges that suck up the sludge and then gravitate it to the sludge treatment and pumping station. Carbonation. The use of lime as a coagulant raises the pH of water, which is very unstable and conducive to scale forming, and the pH needs to be reduced again. After sedimentation, the water flows into carbonation bays where it is stabilized by bubbling carbon dioxide gas through the water. This reduces the pH to between 8.0 and 8.4, which is necessary to produce chemically stable water that will not cause excessive scaling or corrosion. Filtration. The water is now channeled into the filter house, where it flows through rapid gravity and sand filter beds of finely graded silica sand and pebbles. The remaining suspended particles are removed at this stage. The latest filters constructed have a fine sand layer, 600 mm thick, supported on a 500 mm gravel layer. The sand filters are covered to exclude light to less than 25 luxes to prevent algal growth on the filters and not to attract any invertebrates or insects to the water. After filtration, the water has a turbidity of less than 0.5 NTU. The filters are backwashed on a time basis, typically between 48 to 72 hours, to clean the sand and ensure effective filtration takes place. This is done by taking the filter out of service and then blow air through the sand, and after that to pump clean water in the reverse direction through the sand to remove any dirt that has accumulated in the sand during the filtration process. The filter backwash water is then also treated to remove organics, heavy metals, bacteria and other contaminants which concentrate in this water before being recycled back to the inlet of the process again. Disinfection. To remove harmful bacteria and other organisms from the water and to make it safe for human consumption, the water is disinfected adding chlorine gas to the filtered water. The chlorine is delivered to site in a liquid form, 1-ton cylinders, and then evaporated into a gas and then added to the water in a determined dosing rate. Pumping. Water is pumped from the different stations to the different booster stations with dual-stage centrifugal pumps. The size of the pumps vary between 90 million liters per day to the biggest of 300 million liters per day. Pumping pressures vary between 9 bar and 21 bar depending on the destination. Quality monitoring and assurance. Throughout the whole process, samples are taken and analyzed for all the parameters that are changed during the treatment process and to monitor that the required standards are met. Samples are also analyzed in the on-site laboratory to ensure standards are met and reported accordingly. We are committed and contracted to supply water to the SANS 421 Class 1 standard. All the water that is pumped away from the plant is also monitored with an online monitor system that samples and analyzes continuously the main parameters of the water. Today, Zuikerbosch Treatment Works has a nominal treatment and supply capacity of 3,800 million liters per day, and it supplies potable water to the 4 booster stations, Swartkoppies, Palmeet, Mapleton and Eikenhof, situated on the southern outskirts of Johannesburg, from where the water is distributed to our major customers. The following departments stand as a supporting structure to the water treatment in Zuikerbosch Water Treatment Plant. Maintenance Services. This department provides a supporting role to all other departments in the form of civil work, cleanliness around the site, attending to vehicles used around the site, and providing a maintenance planning function for Maintenance Corps. Maintenance Corps. The Maintenance Corps Department provides services to operations for them to achieve their measurable objectives, that is, quality and quantity. Maintenance Corps ensures that the critical plants and equipment are at healthy operating levels and the plant availability and reliability are achieved as planned. Human Resources. As a strategic business partner in the integrated sustainable people-centered solutions, HR strives in creating an enabling environment that fosters attraction and retention of highly skilled and motivated staff. We attract, develop and retain a skilled, knowledgeable and well-informed workforce who operates ethically in an environment where roles, responsibilities and agreed performance requirements are clearly communicated and reviewed in an equitable and just manner. Finance Department. The Finance Department is responsible for all financial inventory and procurement processes in accordance with the Public Finance Management Act and other relevant legislation, playing a critical role in servicing all key stakeholders to ensure an uninterrupted supply of potable water. The key activities are: inventory management consists of movement of stock from the point of purchase to the time it is handed to end user. Some of the activities include materials handling, storage and warehousing, transportation. This also includes managing the waste and salvage area, procurement of goods and services to ensure plant availability and reliability. Financial aspects include petty cash, receipting of invoices, asset verifications, preparation of variance reports including cash flows and budgets. Risk control. The primary function of Zuikerbosch risk control is to protect the human, intellectual, physical and financial assets and resources of Rand Water Zuikerbosch, and to maintain a safe and healthy environment by creating awareness in all sections to achieve regulatory compliance and to promote a risk-conscious climate. The Minister of Police declared Zuikerbosch a national key point in terms of the National Key Point Act. The site is also certified in terms of the ISO 9001, ISO 14001 and the OSAS 18001 protocols. In doing so, we established the following disciplines to protect Rand Water assets, resources and employees. Occupational health, to promote and maintain good health of employees. Occupational hygiene and environmental management, to implement and maintain an effective environmental management system. Risk control investigations, investigate crime and advise on proactive measures to deal with and prevent crime. Quality management. The ISO 9001 Quality Management Program is designed to meet customer demand. Risk control training, to ensure that staff is adequately trained in terms of all statutory training. Occupational health and safety, to ensure that working conditions are conducive to the safety and good health of our employees. Process quality. The primary function of the process quality is to render a service to operations section within the water treatment plants with regard to water quality assurance in order to optimize Rand Water's processes. The Process Quality Department effectively monitors the entire water treatment process that affects the quality of potable water produced in line with Rand Water's strategic objectives. This entails provisioning and management of the site chemical budget, identification, implementation and monitoring of risks associated with the water quality, quantity and quality of bulk water treatment chemical supply that can affect the integrity of water treatment processes. Performing water quality assurance by monitoring of potable water produced by operations as well as the raw water received. Management and interpretation of operational water quality data. Ensuring that all analytical equipment used by operations and online instrumentation of outgoing potable water is reliable, accurate and available. Zuikerbosch Water Treatment Plant is committed to ensuring Rand Water not only meets but exceeds its mandate to deliver potable water to its customers.